Hi, so in this video, I'm going to discuss about for the chemistry trial paper from the MRSM for the paper 2 2024. So let's get started. So first, look at the first question. So this is the questions that shows the drawing of the molecular models for two molecules of the carboxylic acid homologous series. So okay, in this question, we observe that there is a methanoic acid and the ethanoic acid. Okay, so it is given us the molecular model already. So let's go with what is meant by molecular formula. So for information, this is something related to your Form 4 Chapter 3. So we know that actually we have two types of the chemical formula. The first one is the empirical formula, and then the second one is the molecular formula. So there is a difference between the empirical formula and molecular formula. So molecular formula, it is the chemical formula that shows the actual number of atoms of each element in the compound. So what does it mean? So it means that, so in these questions, let us use ethanoic acid as an example. So if I want you to write out the molecular formula for the ethanoic acid, you need to write it as CH3COOH. So basically, it just need you to write down all the letters. Write down all the letters in the atom. So this is actually the atom of the ethanoic acid. So we know that actually we have 1C, 2C, and then we have 4H and 2O. So this is how we write for the equation for the molecular formula for the ethanoic acid. You need to write out all the number of atoms. You cannot simplify it. So if I want you to write the empirical formula tells us that it is the simplest number of ratio of each atom in the element. So since you already know that, it shows that empirical formula gives us the simplest number of ratio. It means that if we can simplify for the molecular formula for a substance, for example, in this case we use for the ethanoic acid. So the empirical formula for ethanoic acid would be CH2O. Yeah. So how I get this answer is actually because this is our molecular formula. So actually, you can also write it as C2H4O2 as long as you write out all the number of atoms for the compound that you need to write. So you already observed that this is actually some of the ratio. This number 242 is the number of the ratios that you can simplify actually. So how to simplify? We can divide it by 2, which is CH2O. So this is the empirical formula for the ethanoic acid, and this is the molecular formula for that, which is we never simplify it before. So this is just how simple it is. So let's go with name all the elements present in both acids. So it's basically just carbon, hydrogen, and oxygen. So you need to know what is element. Element is something that you can find in the periodic table. I believe you will have the appendix during the exams for the periodic table. So all the elements inside that you can find on the periodic table is just elements. So okay, state the molecular formula of the methanoic acid. So let's go back to the pictures for methanoic acid. So as what I mentioned just now, you need to list all the atoms out. So you cannot simplify it, you just write it as COOH, then in front you put a H. It doesn't matter how you write it. If you want to write it as COOHH also can, because you already list out all the letters, all the numbers of atoms in the methanoic acid. But usually people will write like this because it's kind of weird if you put two H together like that. Okay, so this is the question 1B. it gives us the chemical equations that shows the reactions between the magnesium and the ethanoic acid. Step 1, qualitative and quantitative information that you can obtain from the chemical equation. So this question already give you a hint where you must refer to the chemical equations. So next, what we are going to understand is that what is meant by qualitative and what is meant by quantitative. Actually, qualitative is something that you can see. You can see it directly from the equation. Means what quantitative is something related to the quantity. Or another word to substitute the meaning is the amount. So since it is a quantity or amount, so it must be something that we can measure. So it is measurable. So for sure, you will come across some kind of numbers that indicates the amount of the chemical substance that for a particular chemical reaction. So the first qualitative information would be the magnesium. Actually, it reacts with the ethanoic acid to form the magnesium ethanoate. This is the magnesium ethanoate and the hydrogen gas. So this is just how simple it is. It is the qualitative information that we can get from the equations. So similar to what I said just now, quantitative is something that it will related to the numbers to indicate the amount. So now you just have to put 1 mole of the magnesium react with 2 mole of the ethanoic acid to form 1 mole of the magnesium ethanoate and 1 mole of the hydrogen gas. So this is how you get these 2 marks. Okay, let's continue with the diagram 2. So this is a structural formula for the polymer A. So you will know that something you related to polymer, it is actually come from the syllabus Form 5 Chapter 3. So first question, what is meant by polymer? So I strongly encourage you to look through and read through or even memorize the definitions for all the chemical terms that have its definitions. So polymer is a long chain of the molecule that is made out of combinations of many repeating basic units, or we say monomers. So these 2 words you can choose either ones. Either you want to choose it basic units or monomers. It doesn't matter. So second question. Draw the structural formula of the monomer for polymer A. So we are going to draw for what? Monomer of the polymer A. So we already know that polymer is something related to many repeating basic units and monomers. So basically, we need to observe and identify the same unit from this long chain of the polymer. So very obvious, you can know that this is actually the first unit, and this is the second unit, and then the third unit. So this is just how we're going to discover it for the monomer, and then we have to draw it. So we need to draw a C, double bond C, and then the benzene ring over here, and then draw the H. Basically, you just complete down everything, and you need to note that this carbon can actually form the maximum 4 bonds. So this is your answer. So we have 1 bond, this is a double bond, 3 bonds already, and then the 4 bond. Because it is the monomer, so we cannot draw it like this, which is a 2 straight line over here, because it is not connecting to anything. We just want the monomer only. If you draw the straight line like this, it means that you already connect it with another second and third monomer unit, so it will not be the answer. Okay, third one. Name the type of the polymerization reactions to produce the polymer A. So for information, we have this addition polymerization because it involves the double bond. So basically, if you want to add the second unit over here and then the third unit over here, you need to open out the double bond. So we just add the second and third monomer unit into the double bond over here. So that's why we say it as the addition polymerization. Okay, B. The following statement shows the characteristic of a polymer. So the first characteristic is that it disintegrates or burns when heated. And the second one is it cannot be recycled. So B1. State the type of polymer that has the above characteristic. So something related to heat energy. So it is related to temperature. So this kind of polymer we name it as thermosetting polymer. Okay, so the B2 is give one use of the polymer. So you need to know what is the usage for thermosetting polymer so that you can answer this kind of question. So it is to make the bowl or plate or any suitable answer. So for more possible answers, you can search it online or refer back to your reference book or even textbook. So let's continue with question 3. This is a diagram that shows the electron arrangement for the compound P. So A, write the electron arrangement for the magnesium atom. So you need to take note that this is for the magnesium atom. Even though this diagram shows us this is the electron arrangement for compound P, and we know that this is actually a magnesium ion, and then this is another oxide ion. But atom is the original elements that haven't involved for the formations of the compound P. So in these questions, you need to put the electron arrangement for magnesium atom is 2.8.2, or if you want to write it as 2,8,2 also can. So be careful to look at the keywords or the requirements of the question so that you won't lose the marks. B. State the type of bond in the compound P. So this is ion. As what I mentioned, this is actually the magnesium ion, and this is the oxide ion. So when there is an ionic bond, in the compound P, so the type of the bond will definitely be compound P. Will definitely be ionic bond. So write the chemical equations for the formations of the compound P. So this is the answer. So many students will confused like how to write for the chemical equations for the formations of compound P. So you need to know, for a chemical equation, we have reactants, and then it will undergo the chemical reaction, become products. So this is the formations for compound P, and sure you will know this is actually a magnesium oxide. So the original or the reactants that involved will be magnesium and the oxygen. So just copy down the magnesium, react with oxygen. This is the original chemical formula for magnesium and oxygen. And then that will form the magnesium oxide. So for information, if you don't know how to write the chemical equations for magnesium oxide, it would be the Mg2+, which is the magnesium ion, with hydroxide ion. And then you cross it, copy down the magnesium, and then copy down the opposite charge of the oxide ion down, and then copy down the oxygen again, and then you just copy down the opposite charge of the magnesium. Do you notice that these two actually we can simplify it? So after we simplify it, it will become magnesium MgO. So this is the equations for it. But we haven't complete this equation yet because it is not balanced. It is not balanced. So when we want to balance it, the in front must be sent with the backwards. So in front we have one magnesium, and over here at the product side we also have one magnesium. But at the reactant side we have two oxygen, but at the product side we only have one oxygen. So in order to balance it, this is 2, this is 1, only 1, so we have to put another 2 over here. So now our oxygen has already balanced, but now the problem is we have 1 Mg in front but 2 Mg at the back. So we will need to put another 2 in order to balance the equations. So this is how we are going to balance for the chemical equation. So the question D, this is the questions that you need to know. So this is the question that shows us calculate the volume of the oxygen gas needed at room condition to react with 0.5 mole of magnesium, given that 1 mole of gas occupies 24 dm³ at room condition. So this is the molar volume. So in order to calculate volume, the formula would be volume equals to the number of mole times molar volume. So to calculate the volume of the oxygen gas, we need to find first the number of mole of oxygens. So this is how the questions are interrelated. So remember, we have at the question C here, we have copied down, we have write the balance equation over here. So let's move it to the D part. So this is our original equation. So it is given that in this question we have 2 mole of Mg, which is equivalent to 0.5 mole of magnesium. But you need to notice that now you want to find for the volume of gas. So for sure, we need to find the number of mole for oxygen. But isn't that is not provide us any mass or volume of the magnesium, right? So we cannot find the number of mole. So by now, you need to compare for the chemical equation, which is, in this question, we can know that the relationship between the magnesium used and the oxygen gas that we use is 2 to 1 mole. So since 2 mole of magnesium equals to 0.5 mole of Mg, if I want to find 1 mole of the oxygen gas, it would be 0.5 divided by 2. So we will get the number of mole for the oxygen gas, which is 0.25. We need to compare it. So since in this question, magnesium, so I repeat again. So in this chemical equation, we have 2 mole of the magnesium. 2 magnesium. And then this stands for 0.5 mole of Mg. So for sure, over here it will be 0.25. Just like the mathematics, the ratio, we want to get the ratio. So after we get the number of mole, which is 0.25 mole, we can calculate for the volume of the oxygen gas, which is 0.25 times the molar volume, which is already given in the question, 24 dm³. So the answer will be 6 dm³. Okay, so this is the question 4. This is a table that shows us the information of the composition for the glass R and X that are widely used in our daily life. So this is your Form 4 last chapter, Form 4 C8, chapter 8. So it gives us 2 types of glass, R and S. So the composition for the glass R will be substance Z, sodium carbonate, and then the calcium carbonate. And then for glass S, we have the substance Z also, sodium carbonate, calcium carbonate, boron oxide, and the aluminum oxide. So A1, question 4A1, state the substance Z. Do you notice that in this composition, the R and S that has this substance Z as the main composition of the component of the glass? So it means that even though you don't know, or even I believe most of the students will not go and memorize one by one the composition for the glass, but you need to know that in order to make glass, we have the major component, which is the silicon dioxide. So yes, silicon dioxide is actually the sand that we normally see. Yeah. So silicon dioxide, so the sand, in terms of chemistry, it is something related to, it is actually the silicon dioxide. So this will be the answer. Then the substance Z, silicon dioxide. Okay, state the type of glass for glass R and S. So I already underlined that for the glass R, we have the sodium carbonate, calcium carbonate. So actually, it is the most common glass that we know. So the answer will be soda lime glass. This is the very common and very ordinary glass that we use for some common usage. And then for the glass S, we have this boron oxide. So you need to remember that only one type of glass will have this boron oxide as one of its composition, which is the name also start with B, which is the borosilicate glass. So it is some tips that you can remember. For boron oxide, the glass will be borosilicate glass, which also starts from the letter B. So this will be the answer. Okay. So let's go with question B. Diagram 4 shows the containers that can be used by the Buon Saloma to store pickled mango. So this glass jar is used to store the pickled mango. Choose one suitable container to store the pickled mango so that it can last longer and justify your answer. So basically, you need to choose either you want to use the glass jar or the metal container, and then you need to give a reason. Give your reason for your choice. So actually, we can give two types of answers, which is if you want to choose for glass jar, you need to give the answer. So why we choose glass is because glass is chemically inert and safe. It won't react with the pickled mango and maybe produce something that is not good for us to eat. And then for the metal container, it won't break easily. I believe you also, when you go to the supermarket, you can see a lot of the food tin. They are also used for metal. So actually, you want to choose glass or metal, it doesn't matter. As long as you can justify your answer with a logic and reasonable answer, that will be fine. Okay, for question C, in the production of the glass fiber, the glass is heated until it melts and is passed through the fine hose. So this is how we produce the glass fiber. So just how the properties of the glass fiber can be strengthened to form the optical fiber. Step 1, property of the optical fiber. So this optical fiber you need to know first. It is used for the telecommunication purposes. So how we're going to make optical fiber is by you add the plastic. And then what is the property of the optical fiber? It is flexible and then high compression strength. So this optical fiber is actually can be found in the wire of your telephone also. I mean the telephone that commonly used in your living room at your home. So this is the properties for the optical fibers. Okay, question 5. So this is the diagram 5.1 that shows the students were hanging a weight cloth. Okay, so A1. Then the process involved in changing the state of matter of water in the diagram 5.1. So there is a sun, and then this is the water droplets. Then the process involved in the change of the state of matter. So we know that we have three types of the physical state of water, which is solid, liquid, and gas. So the process of involving the changes in the state of the matter of water will be water first, and then go to the second one, which is the water vapor. So the process of the water droplets change into water vapor is simply just evaporations, because we have sun. When the water droplets absorb the heat energy, it will change into water vapor and evaporate. So this is the process of evaporation. So second, draw the arrangement of the water particles before and after the process named in 5A1. So just before. So we know that water droplets is liquid, and then water vapor will be gas. So simply, we just need to draw for the atom arrangement for the liquid and gas only. So we know that this is the pictures for the liquid. So how we draw for liquid is, you draw it one by one, and then they will stick to each other with a little bit of the space between the water droplets. So this every single blue circle is actually represents the atom, the water atom, the water molecule. And then after the liquid change into the gas, it will be something like this, where the gas particles are very far from each other and they have a lot of space in between them. And students, you need to remember that don't be too lazy if you don't want to draw or what, because you need to draw at least 5 or 7 and above, and then the examiner will give you the marks. Because in the previous SPM levels, our teachers also teach us that you need to at least draw it 5 to 7. You cannot draw too little bit, or else they will deduct your marks. So this is how you're going to draw for the atom of arrangement if in your exams it comes out this kind of questions. And you also need to know that you need to draw the size for the atom very uniform. You don't draw it suddenly very big and then you draw it very small like this. This is not accepted because the atoms will always have the same size. So you need to make sure the circle that you draw is like the blue circle, very uniform, almost the same size. Okay, so the third one is state the change in the attraction forces between the particles as the process in 5A1 process, so evaporation. So we need to know that when the particles change from the liquid state to the gas state, what happens to the attraction forces? So what happens would be the attraction force between the particles or the molecules become weaker, because that's why the force of attraction in gas is very weak. Therefore, they have a lot of spaces between each other, meaning that they are not very strongly attracted to each other. Okay, B. Diagram 5.2 shows the atomic model of James Chadwick for atoms W, X, Y, and Z. So based on the diagram 5.2, choose two atoms which are isotopes and explain your answer. So first of all, you need to know this is Form 4, Chapter 2. What is actually an isotope? Isotope is the atoms of the same element. Atoms of the same element that has the same proton number, or we say the same number of protons but different nuclear number. So in order to solve this kind of question, since it's already give you the diagram of the each atoms, you need to calculate one by one for the proton number and the nuclear number. Okay, so for these questions, I don't know whether it is a confusion or is there any mistake for this diagram or for this question, because it only wants us to choose two atoms. But if according to what I have calculated, so the proton number for the atom W, Y, and Z are actually 8, and they also have different types of the different number for the neutrons, which is for W is 8, for Y is 6, and then for Z is 7. So actually, if you want me to give the answer, my answer would be actually there are 3 atoms, which is W, Y, and Z, and then the answer will just be this one, because they are the atoms of the same element that has the same proton number but different nuclear number. Yeah. Okay, for question C, diagram 5.3 shows the information about the natural abundance of Q isotope, and then we are going to calculate the relative atomic mass of Q. So if you know that it is actually, if we want to calculate the relative atomic mass for Q, so we can say relative atomic mass of Q actually equals to the relative atomic mass of the isotope itself, which is, in this question we have 4 isotopes, which is 204, 206, 207, 208, and with its respective abundance, which is, I circled it with the blue color, this one. The blue color indicates the abundance of their isotope, and then this will, the red color will be the isotope itself, which is, it also represents the relative atomic mass. So if you want to calculate it, just times the relative atomic mass, which is the red color, times with the abundance of it. So in this question we will times 2 plus 206 times 24 plus 207 times 22 plus 208 times 30 times 52. And then lastly, we need to divide it by 100, because their natural abundance will surely equals to 100%. If you don't believe it, you can check. 52 times 2 times 24 times 22 will be equals to 100. So let's calculate for the question, for the answer, which is 20722, and then divided by 100 will be 207.22